Start with this. Thanks to everyone for joining this breakout room. I know you had some other very good options, so I'm happy to have you here. Um, in the next 20 minutes, Sarah, Mike Olson, and myself would like to introduce you to what this Excellence in Breeding module is about, the module 2. What exactly is offering to you as partners? What are the challenges that we have been facing in 2020? And what can you expect from us in 2021? I hope you can see that I'm changing to the slide number 2. Please, Solomon, if there's any way that I can hear you, just to make sure that everything is on track, that would help. Otherwise, I'm just going to assume that things are moving well. Um, okay, so let's start from the beginning, and then we will have some time later on for Sarah and Mike, and then some time for Q&A session. I think we have about 20 minutes for Q&A session. So I will go very quick on this part. What is this module about? So some of you have been talking with the Module 2 team already. So Module 2 is about optimizing your breeding scheme. Um, Many of you work together with the Module 1, with Peter, before with George, to define your targets more clearly, the market segments. So once you have been familiarized with your market segments, you have mapped your pipelines with these segments, and you can describe your breeding scheme. You probably want to design your breeding scheme in a way that returns you the maximum rate of gain in varieties per dollar invested. So for that, we need to look back at a breeding process. So I'm trying to put this in the slide, a process with many pieces that can be fine-tuned. Somehow you have many levers there, so you can improve the different aspects of this process. So module 2 is about helping you formalize first this breeding process. For example, helping you to create this blueprint or the breeding scheme that we are always referring to, and then helping you think in terms of decisions that go throughout all this process. So the crossing decisions, evaluation decisions, selection decisions, and how the different methods and tools that have been developed in the last, not decades, I would say centuries, in breeding can be used to improve your breeding program. Think on how you can make all these changes, and what will be the impact of adopting certain changes in your own program. And of course, link with the pertinent modules from Excellence in Breeding when it's time to move to the implementation of some of these changes. We tend to say that Module 1 and 2 are trying to help you redesign or design better your breeding program, whereas Module 3, 4, and 5 are trying to engineer all these changes from the design that you're coming up with. So what Crops to End Hunger and the Module 2 promotes is to, as I was mentioning, redesign the breeding schemes to move from a more product-focused philosophy to a philosophy that actually tries to somehow use the population improvement as the base for developing the products. So it still is a product development approach, but that is actually based on a strong population improvement idea. This is with the purpose, of course, of increasing the rate of genetic gain and move the distributions of the breeding values for the different traits that you are interested. So that's what we tend to call the population improvement philosophy. So we promote to change the focus from what currently in many programs is intense or high intensity programs, so big in size, we rely a lot in just storing diversity, to programs that are of a more moderate size, but that are focused mostly in accuracy and speed, without, of course, forgetting the others. This is because we know that this approach to increase the rates of gain can also increase the likelihood to find better products. I would like to make a small comparison to that. We're trying to kind of move from creating this big vehicle that several programs are in this philosophy. So look at it as the first line that is on the top with the big truck, that has become big and somehow is low because of the concern of running out of gas or diversity. And That, by the way, also makes that this particular vehicle makes multiple stops actually very often to keep loading more and more gas throughout the road. And we are trying to move into developing a smaller vehicle that has just enough gas to get to the finish line, which you can see it as the product, that can move fast to the next loading station and then again move to the next product, but that somehow can calculate how much gas is really required to get to the next or the next stop. Just like when in your car you can see how many kilometers you can expect that your gas is going uh, to help you get there. You also can calculate that using some of the principles on quantitative genetics. And instead, like I said, it's focused on going fast and also being accurate. Like I'm just trying to depict it here, like if you were using two different systems of finding your way. Google Apps versus, or I'm sorry, Google Maps versus maybe just a typical map. Um, so what this module exactly offers to the partners, in this case, of course, you. The most important, from my perspective, is the direct support to the crop by region priorities defined by the donors, to help them formalize their pipelines, assess their breeding strategy, their decisions, also provide simulation support and retrospective analysis support uh, to understand what would be the effect of doing certain changes. And of course, also provide, like I said, the link with other modules. And on top of that, try to help you on building capacity with trainings, forums, and manuals. Um, Solomon, is still people following me? Because when I am in the presenter view, I don't think I can.
Yeah, we can hear you perfectly.
See too much of the interaction.
Yes, Eduardo, we are hearing you.
Okay, just wanted to make sure that you can see the change of the slides, etc. Good. So, what are some of the achievements of this support provided during 2020? I think that one of the most relevant was the opportunity to allow breeders to reflect about their process. Like I said, we are just trying to guide you. You are really the ones that make the magic, and put all those breeding schemes in a document and kind of formalize your blueprint. Understand that this should be a process that needs to be kind of steady, so you can actually make changes and not just making changes all the time without knowing what is the effect of such changes. So we have to make, or we have made this with dozens of programs, and this has become like the seed that is germinating in many programs. To look for more changes, to improve even better, make more correlation analysis to identify what is going to pay more. So in those meetings, I would say we normally discuss the potential improvements that can be done, and then we can move to the next one, which is the actual one-to-one support. That it can be, one of those is of course the simulation. We've been trying to simulate many different questions for different programs that at some point we really want to summarize in the training that Jan was referring to in the past presentation, and in some sort of 1 week training on quantitative genetics, and that will not only go on the theory but also on the findings on how the different decisions can be really used to have a good breeding scheme. So as I was saying, up to now we have been simulating many things like recycling strategies, selection indices, the effect on heterosis based on diploidy, and then inbred versus non-inbred, etc. GS implementation. And of course, for some of you, it might sound familiar, some of these, and some others will not, because different programs have different questions and different improvements that they want to focus on, and there is things that need to be addressed, like optimal ways to make introgression, experimental design, optimal contribution, different use of selection units, and how to balance the selection at different stages. In these simulations, we normally build the crop with their genomic characteristics or features, their parameters that are customized to the breeding program, and we run alternative scenarios to see what would happen at the end of certain time frame if a given change is made. For example, the one that you can see on the lower right corner, um, is that one is about the changes expected if the tested material in the yield trials and recycling would happen earlier. So you can start to see what to expect on the rate of gain over time if you were to, for example, accelerate your cycle time. This is the particular case of, I think, Seat beans, from moving from using the F7 to an F5 PYTs. Anyways, the simulation is one of the things that, of course, you can always get the support from us. You know that I will refer later on to the challenges. Sometimes, of course, the simulation only works when the data is not available, because generating such data would be too expensive in terms of time, money, etc. So when the data really exists, which for many programs is the case, especially the robust programs, then we can support in a different way to answer the questions with respective analysis. The image, for example, in this slide refers to the question on how many environments are optimal to for the yield testing in the CIMID maize program that we were working together with Joseph, a very modern breeder that works in Africa. And the point that I'm trying to do is that sometimes I like to always highlight that the tool, um, tools like Six Sigma or simulation are exactly that, just tools. It's not the final goal. It's just the way to actually understand better the change in certain decision. But at the end of the day, we need to actually move to additional steps. Once we understand the question, we understand the answer, then we need to actually um, understand also what would it take to move this to an actual implementation. Um, anyway, I'm trying to go as fast as possible. I think I still have 3 minutes. In the capacity building, we have celebrated a training on how to apply continuous improvement tools like Six Sigma in your breeding schemes. This happened in February. We had another one scheduled for July, but then the COVID stuff didn't allow us to run the second training. Um, but I think this was actually one of the successes from 2020. Um, I hope you have also attended the COP meetings, a forum to discuss ideas, tools, and methods to optimize your reading schemes. And I hope you have also taken a look at the toolbox where we have stored the manuals, scripts, and we will also put there in 2021 the videos and a nicer structure to help the optimization of breeding schemes. Good. So the challenges that we found in 2020, I think you probably identify this quickly. We unfortunately didn't have the critical mass to attend all the number of pipelines and programs that we want to support. That has been changing recently. I mean, the staff for Module 2 has increased. Now we have another 2 quantitative geneticists that will be supporting this crop by region priorities. So you can expect more support in 2021. And for certain improvements and suggestions, that the lack of the use of the data has been also a challenge for us. I'm referring specifically to the use of selection indices. That normally when there is not a data used or data culture, then it turns out difficult to implement certain improvements. It has been also difficult that I was referring that at the beginning. So, understanding the advantages of really taking a population improvement versus a product development philosophy. It's not that the population improvement doesn't care about product development. Actually, that's still the main focus. It's just what is the basis to get to better products. And that has been sometimes difficult, and probably mostly our fault in conveying that message in the proper way. And of course, another challenge has been that so for some programs, the market segment part and product concepts, etc., has not been completed or has been super confusing. So if we don't start from that assumption or that part very clear, then the design of breeding schemes is also, I guess, it becomes difficult. Um, what you can expect from us in 2021, well, we're going to work on delivering some GUIs, user interfaces, to design your breathing schemes, to make some simulations by yourself, and what we call the breathing scheme descriptor and breathing scheme designer, and more direct support, as I was saying before, and new trainings, as the one that Jan was mentioning, that it was not really a simulation training. It's a quantitative genetics training that will try to bring everyone to the same level in certain aspects where we feel that we can support. I'll stop here and I'll pass it to Sarah and Mike, and then we can go to the Q&A session. Sarah, can you take from here? Solomon, can you hear Sarah? Is it only myself or?
I can't.
Sarah, are you sure that you're not muted?
She's not, actually. She's not muted.
Okay. Then do you want to maybe leave the session and try to join again? If that works, yeah, I think she's going to do that. I guess on the meantime, I can just read one of the questions, and then of course, very quick, just to don't steal the time from Sarah. It's a question from Flavio, and about suggesting a robust historical data set of METs that could be used to promote the efficiency of a long-term program. Okay, yeah, I think that's a good question. I don't know if I should save it. Sarah, do you want to take from
Can
here,
you hear me
and I
now?
will provide the answer?
Am I
Yeah, we can hear you now.
Hey, at last, technology works. Okay,
Yeah.
apologies for that
Yeah.
technical interlude. So I'll take it away very quickly, Eduardo, and we can come back to that excellent question from Flavio towards
Yep.
the end. So I'm going to go through on behalf of myself and Mike Olson some ideas around the trait pipeline optimization. So those of you who remember EIB from the early incarnations, we did have trait discovery and trait deployment described within the initial proposals. That work was de-emphasized to some extent, given the importance of getting the bulk of the breeding pipelines optimized. But now we are re-engaging en masse. So what do we really mean when we describe this process? We're talking about that continuum from the discovery of new traits, identification of new donors, mapping of traits, validation of primary traits, and the development of bridging germplasm, all the way through validation to the deployment of those traits in elite backgrounds. So we're talking about the development of new breeding germplasm. Can everybody hear me? I see a couple of messages in the chat.
Yeah.
Okay.
It seems a couple of people cannot hear you, but
You to deal with that in the
I'm
chat.
just.
Thanks, Eduardo. Okay, so this is the space that we're talking about. And in a similar way to the main chunk of the breeding program, as Eduardo articulated, we want to try and look at how we best separate different functions to improve the production of targeted germplasm. So when we think about germplasm management, we're talking about needed variation into the new germplasm pools. So really sourcing alleles without interrupting the rest of the elite breeding pool. The last thing that we want as breeders to do is set our elite breeding populations back, introduce an awful lot of linkage drag. And the way that we've tried to conceptualize this is using this really nice quadrant diagram that Mike Olson conceived. And what we've done here is try to split germplasm across two different continuums. One is looking from poorly adapted germplasm up to germplasm that is really well adapted to the target environment. And then the second continuum looks at competitiveness of that material, from our elite germplasm pools all the way back to material that really is uncompetitive. And when we look at this upper quadrant in the right hand here, this orange box, this is essentially the breeding program, those closed programs that Eduardo was articulating. So this material is outside of the scope of the work in trait discovery and trait deployment that we're talking about. So there are many different sources of traits that we can look at. We can start to try and look for traits in materials that are just outside of our target population environment. So other varieties, whether they're improved materials already, all the way back to wild relatives and land races. Now, obviously, those materials require a different strategy. They require a different exploration and deployment strategy if we're thinking of dealing with that germplasm as a donor. So when we started to think of this, we started to list out some of the things that we considered important in terms of a needs assessment. So before we start looking for any additional variation, the first question that we should be asking is what variation exists already in our elite pool? And the second question is really very relevant and connected with this, which is there a repeatable and affordable assay for the trait of interest? Over many years of experience, we found that in many cases, we go on hunts for new variation without really being able to assay the existing elite pools for that variation. In such, it's not a genetic variation challenge, it's a challenge of being able to assay the trait in an accurate and repeatable manner. If we have identified the need for additional variation, another question is what would be the economic or development weight of the trait? And how urgent is the market need? Really trying to integrate these activities in with that market demand. What is being demanded from the markets, translated through the variety product profiles, and then back into this pre-breeding work, the trait discovery work. When we consider traits, how many market segments could potentially be impacted by the trait? Are we looking at something that may be niche? Are we looking at something that's really could have scalable impact? What is the plan to mainstream these traits into variety product profiles? What germplasm sources are available? As I mentioned before, are we dealing with germplasm sources that are much closer to our elite material, or are we dealing with something that's really still very wild and untamed? Are trait genetics known? Are marker trait associations or genes known? And there are many other questions that we can start to put in here. And what we need to start thinking is how we strategize this questioning, what kind of weighting we put on various questions, really to decide first and foremost whether trait discovery and trait deployment is needed. We try to put these questions then into the framework of a decision tree. This is an example of some of the questions we could ask around discovery. So one common question could relate to the crop biological constraints themselves, thinking about breeding systems, whether materials are clonally propagated, inbred, hybrid. These are all relevant when we think of the kinds of populations that we could create for development and discovery purposes, and whether those populations are really could be leveraged over wide scale to do decent phenotyping. Thinking about the genetics of the trait, the complexity of the traits, the potential inheritance modes that we're dealing with. Again, those same questions about assays, questions about the adaptation of potential donors to the assay environment, and then another question of what available data do we already have in terms of genomic resources, phenotypic resources, and other data sources such as environmental data. All of these could be compounded and weighted in a way that we can then select optimal approaches for discovery. And there's just a couple of examples here, whether we're going for polygenic traits towards a GWAS or a genomic selection kind of model development strategy, or whether we can really focus on something that is much simpler inherited, where we could quite cleanly implement a biparental mapping strategy. Now, the discovery does not always go hand in hand with the deployment of materials. Sometimes they work very well coupled together. Sometimes they do need to be separated so that we can optimize the generation of both markers and germplasm. On the deployment side of things, the decision tree again could have questions around the biological constraints that we're dealing with, again, the genetics of trait complexity, and then other questions around freedom to operate. Okay, are we dealing with alleles or haplotypes that have particular stewardship or IP? How elite is the donor that we're dealing with? Okay, that would have quite a different strategy in terms of how we try to limit the impacts of that linkage drag that we will inevitably have. What are the quality of marker trait associations? Are there available production markers? All of these questions, again, will derive into different strategies and decisions around the deployment and generation of that new germplasm. And again, we've talked about separating these activities from the main pipeline so that we can have clearer stewardship of the processes. But that doesn't mean to say that they stand alone, divorced from the rest of reality. These pipelines, while separate, all these activities while separate, need to align and embed quite clearly within the rest of the main breeding pipeline, and involving the rest of the staged processes as part of that. So one example would be the selection of recurrent parents that we might want to conduct. We don't necessarily want to go back to the oldest mega varieties that are out there. Yes, those materials are very successful, but when we consider the time involved in the development of this new germplasm, we should be trying to tackle the most elite materials coming out of the main breeding pipeline that Eduardo spoke to. So those initial things coming out should be the materials that we're using as recurrent parents, so that after the 3, 4, 5 years of trait discovery and deployment activities, that is still relatively elite to plug in to the rest of those breeding pipelines. When there is a choice, we should be selecting the most elite germplasm donor, the most adapted, the one with the closest genetic similarity to the recurrent parents that we've chosen to use. And obviously from species to species, there's going to be a slightly different weighting in the way that we want to look at these parameters. And throughout the processes, we need to be defining the needs and the thresholds for both equivalency and efficacy testing, so that we have a very clear stage-gated system and clear decision points that can be well described and articulated as we move through trait discovery and trait deployment. So what do we anticipate doing in 2021, and what should you expect? Firstly, we want to engage in a large activity around shared learning and understanding of existing approaches. Different breeding programs tackle this in quite different manners. A lot of that reflects the breeding systems of the species involved. A lot of it reflects the differences in trait complexity. So we want to have an activity where we map the current state in a similar way to the way Eduardo mapped current states within the rest of the breeding program. And really to try and articulate within the programs what has been working very well and what hasn't been working very well. To look at some of the definitions of quick wins, some of the no-brainer changes which can be implemented now. Again, looking at things like selecting the most elite recurrent parents we possibly can, rather than diluting that effort by selection of a parent that might be great for a trait mapping approach, but really isn't great for germplasm development activities. So trying to work out how we best separate those things and provide some early win guidelines. To engage with simulations, building upon the work of Eduardo. In some cases, there's a lot of questions and open questions still that we can start to tackle through simulation. And then through those activities to start to map out as a collective process with everybody involved in this space, some ideas initially of early collective ideal states so that we can move forwards. And with that, we'll start to take questions. So Eduardo, through to you as well.
Okay, good. I think we are on time. So let's move to the Q&A session. I don't remember, Solomon, how much time do we have for Q&A? But please, if you remember, just stop us when you feel that we should go back to the main session, if possible, Solomon.
Sure.
Yeah, just keep us on track with the time, and we'll do the rest.
Okay.
Good. So let me start with the first question that is on the chat. I also assume, Solomon, that you're going to allow people to make the live questions, I guess, when they request a video and audio. Is that correct?
Yeah. Yes, that's correct.
Okay, so you will get you will be in charge of that. Let me start then with the question that is on the chat. When I finished the presentation, Flavia made a very good question with many components. So let's try to dissect it. It says, how do you suggest a robust historical data set of METs could be used to promote the efficiency of a long-term breeding program? I guess we would need to understand better efficient in which way. So let me take this one level up. Normally, the use of the MET data, or the multi-environment trial design data, for the ones that don't know this acronym, maps back to the evaluation decisions. We were referring to crossing, evaluation, and selection decisions. This maps back to the evaluation decisions, and normally the evaluation decisions map back in the breeder's equation to the intensity and the accuracy of the program, this little I and the little r. So there's always a trade-off of these two variables. To have, for example, high accuracy, you want to use your plots to cover the TPE properly. But you could also, for example, by putting more replication, you will reduce the intensity of the program, and the other way around. So you want to find that sweet spot. The whole point is, of course, to accurately select the highest genetic merit individuals for that particular TPE. Whereas the intensity is kind of a tricky variable, because the increase in size doesn't really increase the rate of genetic gain linearly. Anyways, to go back to the question, the best MET design is the one that I guess it finds the best sweet, or the optimal sweet spot, or the sweet spot between the intensity and the accuracy for the two purposes of the breeding program, the population improvement and the product development. For that, Flavio, you may want to ask yourself a couple of questions prior to that, like how many testing stages you have in your program, at which stage are you recycling, how broad or complex is your TPE, and based on your answers to these questions, then I guess you can decide what is the best MET design, and of course how you're going to use that data. For example, if you were thinking in population improvement, you want to allocate the resources to cover the TPE as much as you can. For that TPE, I mean, you can use sparse testing, the use of relationship matrices, augmented designs, etc., because you may want, for the population improvement, to go fast and accurate. So you just want to use your plots to recycle as quick as possible, but make sure that when you're recycling, you are recycling meaningful stuff, that the breeding values that you are estimating for the different traits are accurate, or are at least as accurate as possible. And that's where some of the simulation exercises can help a lot. But for the product development, you may have a different focus, right? I mean, you actually want to have replicated designs, cover the TPE more broadly, etc., etc. So I would say this is there is not like a definite answer to this question. I would say that that's where the simulation exercises can help you. For example, we're going to start simulating these questions for the rice team from Erie, Seat, and Africa Rice next month. to understand better the genetic model of what is driving it. We know the principles because there is a lot of literature on this, and there is also several CG teams that have made fantastic work on sparse testing, etc. For example, the BSU from CIMIT, and you also have some papers from the ICRISAT team, CIP, CIAT. And there you already have certain answers on how to apply certain methodologies to maximize the accuracy and the intensity. But basically, the answer is there is a trade-off between these two variables. When you are trying to think what is the best met design, you have to consider these two variables adapted to your particular situation. Like I said, thinking on your stages, the complexity of your TPE, when are you recycling, etc. And then you can simulate possible scenarios to find what is that sweet spot. But I hope this at least opens certain additional questions for you to answer. Okay. Is there any other question, Solomon, that is waiting on maybe on the live session, or should I read the next comment?
You can read the next comment. There's no request for live.
Okay. I guess I thought this was more interesting for you than the previous session, but please feel free to ask some questions. We know that there's still, like I said before, many things to be answered, and we are trying to help. Wolfgang is saying, is just a comment. He thinks that with respect to the multi-trait or selection index, there needs to be more awareness about the importance in population improvement on the CG breeders, but also within EIB. I definitely agree. I mean, the selection indices is something that I consider should be one of the priorities for breeding programs to optimize their breeding scheme. To basically not to remove this eye of the breeders method that sometimes people, that's how they call them, but mostly to formalize those methods and in numbers and something that can be written in a piece of paper and can contribute to know if the population improvement that in product development that is being done it really maps or matches with the market segments and the priorities that have been declared in the pipeline investment cases. I can see that someone is sharing a slide. Is that for now, Mike or Solomon, or?
No, it's for the next step.
Not for the next, but could you share the previous? Sorry, Sarah, could you share the previous slide for this?
Good. So on the meantime, is there any additional question with respect to the support? I mean, we're trying to be clear on what we consider are the success or the success examples or successful examples of what happened in 2020, but also the challenges to make you aware of how we see things and also what can you expect from us in 2021. But I would like to also maybe hear from you if there is any particular concern. Also, if you see things differently, feel free to tell us and let us know. I think you have interacted for quite some time with us. You know that we are trying to help.